What's up, guys? How you guys doing? Or actually, I shouldn't have started yet. But I started anyway, bro. So anyway, just gonna make this very quickly. Sorry, guys. Sorry. So I don't need any volume, I don't think. So yeah. What's up, guys? How you guys doing? So my name is Sinalo Jabe, for you who don't know who I am. And if you didn't catch it, I started a new project called Leveling Up. You feel me? The name of the project is called Leveling Up because I'm like upgrading my mathematics and my life sciences. So I'm literally like upgrading my marks from like this to something else, which I'm hoping this. Okay. And of course, this is my quest channel. And so if you're interested in like life sciences, like content and like mathematics, be sure, bro, to like hit the subscribe button, hit the like button, and if you want to be notified every time I drop, just hit the notification button. With that said, let's get back to it. I also want to say, I'm not a tutor. That's very important. I just want to stress this. I'm not a tutor. I'm gonna be making a lot of mistakes here. So don't like if you like writing an exam, like I don't know, a day in a day's time, don't watch my videos. I like repeat like dead ass, bro. Because I'm gonna be making a lot of mistakes because I also know tutoring, so I'm just studying like this. But that said, I'm gonna like get it right though. Anyway, what now? Okay. So, in today's video, what's gonna be happening is that we're gonna be doing two things. First, we're gonna look at some notes about like the exponential graph. For me, you can see on the screen. I don't know why I have like two of these. But if you can see here, we're gonna be looking at what? Exponential graphs. Am I trying to make this cool? I don't know. Why am I doing that? I don't know why I'm doing that. Yeah, I'm just making it cool, bro. Yeah, I don't know why I'm doing that. Anyway, talking about exponential graphs. First thing, we're gonna look at notes about exponential graphs. Second thing, we're gonna do past papers, like random questions and like past papers. I'm actually picked two, so stay tuned to see that it's coming. Anyway, I think the first thing, I want to fix this also. Remember, I kept saying parentheses. I was like, oh my god, brother, there's this guy. I think maybe some of you are like, bruh, do you actually know that parentheses are like brackets, right? Like you know that, right? I'm like, damn, bro. Like watching that video, I'm like, okay, I'm dumb. I'm officially dumb. Anyway, we're gonna be actually looking at parameters and parentheses, and to also avoid the entire thing of like naming these things wrong. What we're gonna be looking at, the functions of the variables in an exponential general form or general formula or whatever. For me, so we're gonna be looking at the effects of A, which we talked about previous video. If you didn't check that video, just go back, bro, because I've already posted two videos already. So just go back and check that out because it's fine. Okay, and also we're gonna look at the effects of B. Yeah, but not we're gonna look at it, and then we're gonna look at the effects of P. Why did I write that? What is that, bro? Effects of P. So when I'm saying effects of A, B, P, and Q, what I mean is that how are these variables affecting our function, our graph. So if we have a graph, how does the value? Oh my god. So if we have a graph, how does the value of A affect my graph? And just a little quick tips to show you guys that I learned from my mistake previously is that like really like compresses. This like compresses and not like it doesn't make it steep. It compresses it or it stretches it out. So that was very important. That was a very important thing to learn. And now it's like so it's engraved in my head. I don't think I'll ever forget it, bro. Anyway, let's go on. Let's go. So yeah, we said we're gonna look at those, and let's see. Notes. There we go. So now, there we go. I said we're gonna look at exponential functions, right? Functions of the form y is equal to a times b to the power of x plus q. So if you guys can see from here, I don't know, should I make it big for you to see? Okay, oh, that's too big. Yeah, then that's fine. So if you guys can see, you can see here there's nothing on x, nothing happened on x. Okay, that's too big. So you can see like nothing happened on x, it's just x. You feel me? But you can think of this guys as like minus 0 instead of like there's nothing. You see, there's always a value. So it's like I don't know, bro. This is my first time doing this. So it's a times b to the power of x minus 0. Don't say it's just nothing. Feel me? Plus q. Anyway, this then goes on to say that functions of the general form y is equal to a times b to the power of x plus q for all the values of b that are greater than 0 are called exponential functions. Okay, now I did not know that. Didn't know that. So they're only called. This is only called an exponential function if we use values of b that are just greater than 0. That's very interesting. What about, I don't know, values of b that are, can it? No, that doesn't matter. That's actually very, very silly, bro. Look at this. If b is like, okay, now. I was gonna say something now, but now I'm seeing that it's actually like wrong. So anyway, guys, so make whatever you want of this. So functions of the general form y is equal to a times b to the power of x plus q for all the values of b that are greater than 0 are called exponential functions. Okay, where a, b, and q are constants. Okay. So now I said we're going to look at the effects of a, b, q on our function, our graph. Okay. So what it says here, it says the effect of q on vertical shift. So now there is it. I think that's the first thing. Is that q shifts our graph vertically. You feel? So for me, I don't know about you guys, but for me, guys, this is like, it's like very tricky to like understand. Like for me, like it's tricky to distinguish between like something that hits, that like shifts the graph vertically, and like where it cuts the graph. I think there's just always like this crazy thing, because like look here, you can like easily like make a mistake here. Okay, if I don't want to use this color, I use black. So look here, like you can easily like make a mistake here. So if you have a function like this, you have a graph like this, and they say that your graph is shifted vertically to the, oh my god, bro. I don't know, maybe shifted vertically. You can put this here, right? Can you see what I'm trying, where I'm getting at here? So this is our graph. Don't get confused. But so look here, this is our come on, bro. So this is our x-axis. Okay. This is our, okay. Why is my graph like this? I know, guys. Chill. This is my y-axis. Okay, this is then my draft. Okay, we're gonna call this f of x. Oh, let's not call f of x because it's gonna just so now, but it's gonna just take time, isn't it? Do you guys know f of x right now by this time? So f of x is just like it's the same thing as y, but it's saying it like it gives us the conditions of y. Like you feel what I'm saying? So like for example, f of x says what does it gives us a general formula of finding y for every x value. That's f of x. You feel what I'm saying? So for example, we can say that y is always 2 times of x, so that's a general formula for finding y. So we use f of x instead of just using y. I would have used y, but that would have confused you guys because this is also going to be y is equal to something. See, that's a cube. You feel me? So here, let's say y is equal to, I don't know, y is equal to like, I don't know, bro, -2. You feel me? -2. So there. So I don't know, this function can be given by what? So what is the question function? I don't know. It can be given by the equation. I'm trying to think of an equation now. So let's say we have f of x okay, this is actually very slow than I thought. Is equal to let's say a is 1, because now we're not looking for the like only looking at the effects of q. Remember this guys is also q, but you're gonna see very soon. Then our b is, this is now very important. We want our graph to decrease, so I think it's gonna have a fraction. B is gonna be a fraction. I don't know if you guys remember from like the video I made. B is a fraction. Then to the power of x. Remember now, I said it's very important. Let's do this. I said it's very important to note that p is 0. Just think of it like this. It just like helps you a lot when you're like, oh, well, p is just 0. So can you guys see? So if you're wondering, okay, like what's going on here? Where do you find this? Okay, this is 0. This is a. Our a is 1. This is our b is a half. Then it's raised to the power of x minus 0. This is our p, and this is q, which is the -2. So I want to just make sure if this is how it really works. Like, does our draft decrease when b is like a half? But I don't know, when 1 is -2, whatever the graph. Oh yeah, I think that's right. That's right. When y is 2. Yeah, definitely. Oh, this graph actually it goes. It doesn't go like up there. It like goes down. Oh my god! I just like created this graph. Now it's giving me like problems. What the fuck? Oh, can I do this? Do this quick? Oh my god! Nah, this won't be quick. This won't. It will cut the entire thing. Look at this. Okay, this is should done. But it goes something like this. You feel me? It goes something like this. Cuts the graph here at -1. Something like this. Okay guys, forgive me, né? This is just so messy and fit. You try to take shortcuts, but it goes something like this, guys. You guys can see I'm trying here. It cuts the, where is it, 1. This is like -1. It cuts the y-axis at 1, and it cuts the what? Where does it cut? Here. Or if you like wondering where do I get the 1, How do I know that it cuts this at 1? Is because you just can say, well, you guys remember this, like, for x, for the x-intercept, guys know this is like taking 4. So I'm gonna just say this for x-intercept. So for x-intercept, this is actually very like, oh my god, bro. Oh no. That was gonna be easy. So this was not easy. For x-intercept, let y be equal to 0. Remember. Okay. Then for x-intercept, let y be equal to 0. So now this is not the y-intercept that I found. This is not the y-intercept that I found there. I'm just doing the x-intercept now. Now I'm just trying to do it in my head. It's 2, then bring it down, then log a half. So it's gonna be log 2 over log a half. So it's gonna cut our graph at also -1. Okay, that's very interesting. I'm like, oh, okay. So it cuts our graph. Both. Okay, we can do the math here. 0 and 6. So for y, so in the place of y, remember I said this was y. I'm pointing, but you cannot see. So I remember I said this thing. We said this was y. So in the place of y. Oh, guys, why am I explaining this to you? I think you guys know this. I think you guys know this. So 0. And then this just becomes a half, you guys know that, right? So this is just a half. So half times 1 is a half. That's where I get the value to the power of x, like -2. So then what you do is that you just go further. Okay, wait a minute. You go further, you can take 2 to the other side. Well, that's very important, right? So you're saying you take it to the other side, but what actually happens is that you plus 2 in from both sides, right? So it's gonna be positive here. So you plus 2 this side, also plus 2 this side. This cancels out, and then you only have like a half to the power of like x left. You see, like, it's taking so long, this, and I haven't even talked about parentheses. Right. Then you can use logs, if you know what I'm saying. I think you guys know what logs is. Now I think someone has to be like in grade 11 to do this, because I don't think you talk about logs in like grade 10, do you? So you can use logs in either way you want. You can use the easy way of logs. So you just say x is equal to log. So now the easy way to remember this is that we use logs to like simplify our equation when they have exponents. So now when we introduce logs, we just want to bring down our exponents. You feel me? Like I did here. So we have this comes down that side, and the base, what was the base, remains the base. So a half is gonna go here. Remember, it's the base, so it's here. But in this, the big value, it's gonna be here. You feel me? It's gonna be 2 right here. So this is the value. This is the value of x. Let's see. Did I do this right? Oh, yeah, I did this right. So this is gonna give you like -1. Hence, you can then say, oh well, our graph cuts the y-axis at -1 and 0. Yay! That's fine. Okay, that's that. I don't know. Then to find where the graph cuts our our y-axis, you just say let x equal to 0, because on the line, on the y-axis, our x is 0. Okay, then when you put 0 here, you have a half to the power of 0, that's just 1, minus 2. So wait a minute, oh, it's just positive 1, so positive 1 minus 2, it's going to be negative 1. Then hence why the graph cuts the y-axis at 1. But if I'm moving too fast, sorry, because I just want to finish what I wanted to do, you feel what I'm saying? Because now I can be saying this and you guys really like understand this. I'm like, oh my god, why did I waste my time? Like, why did I waste time like explaining that, but you guys already understand. So now I was explaining why it can be confusing, like because now they're saying that Q shifts our graph like vertically. You feel me? What that means, it's true. It's true. They say it shifts our graph vertically, like this. Feel up. So this is vertical, right? So it shifts our graph like this. You see now, it cuts our graph horizontally. That's the crazy part. That's how I like always like confuse it. Now that's the thing. I think that's, let's say that. I think it's important to say that. That P. Oh, come on now, dude. It's important to make this. Okay, wait. It's important for us to make this distinction. So P, yes, it shifts our graph. Okay, well, should we make this big? It is big. What the fuck? It's actually very big. What the fuck? Okay, well, let me not say anything. So first, I think it's very important to first say A, it shifts our graph vertically. Okay, vertical is this, but also it's very important to understand. But it cuts our graph horizontally.